Let's take a look at another definition, that of the local relative extrema. If there's an open interval containing C in which f of c is a maximum, then f of c is called a local, or very commonly referred to as a relative maximum of f. Now, if there is an open interval containing C in which f of c is a minimum, then f of c is called a local or relative minimum of f. So let's take a look at a quick picture here. Get an idea just what this is saying. Okay, here, this is a maximum if I think about, well, let me bring this up just a little bit. Okay, this max right here, this is not the absolute max. If I make this a solid point right here, the absolute max could be way up here. But locally, if this is C, locally, if I take some interval close to C, arbitrarily close, every value of x passing through C here, every one of these guys, C, f of c, is the biggest guy. So this is a local maximum. Likewise, right down here, I can have a value of c that I have some interval such that this value is the local min. Now, if I bring this down a little bit more, the absolute would be here. This is the absolute max, like I already said. But these are local maxes and local mins. So about this general region, about this region, this guy is the biggest, this guy is the smallest. That's what that's actually saying. Now, with that comes a definition of theorem that we can use, extremely useful if we start doing some type of analysis on a function. Let f be defined at c if f prime of c is 0. That's the first derivative evaluated at c equals 0. Or the first derivative evaluated at c is undefined. Then c is what's known as a critical number, or I commonly refer to it as a critical value of f. If f has, here's a theorem, that's where this comes into play. If f has a local min or a local max at x equals c, then c, the c that the min or the max happens at, has to be a critical number. That's extremely important because that just told us how to find all these local mins and maxes. So let's go back to something that perhaps looks like this. Here is a local max. Now notice that the slope of the tangent line is going to be 0. That's what this is saying right here. So if this is c and f of c is a local max, the slope of the tangent line must be 0. Likewise here, if this is c, here's my min, the slope of the tangent line at that minimum is also 0. So that actually gives us an actually very nice recipe to identify where these local mins and maxes are at. And it's all based on the idea of the first derivative. So here's a quick outline of a procedure that you can follow to locate extrema on an interval. Now assume that f is continuous on the closed interval a to b. I said assume, but you better double check it, because if it's discontinuous somewhere between a and b, then there's going to be issues. So local or locate, should be locate all critical points in AB. These points are candidates for the local and absolute minimums and maximums. So I want to find all critical values. This is like an xy coordinate for a critical value. These are my candidates for local mins and maxes. Now I'm going to evaluate f at the critical points. That's where the first derivative is either 0 or undefined, and at the endpoints of the interval. Okay, and at the endpoints. Now the largest value is going to be the absolute maximum, and there can be a tie. I can't have two values that are the absolute max. The smallest is going to be the absolute minimum, and again there can be a tie. Local mins and maxes occur when the first derivative changes sign at the critical point, which is kind of obvious in a way. If you draw a picture, let's just say I have this interval from a to b, and I'm looking at something that looks perhaps like this. Now this right here is going to be a local max. Now look at this, the tangent line, the slope of the tangent line is going to be 0. But see, the slope of the tangent line prior to that point is going to be positive. The slope of the tangent line after that point is going to be negative. So it changes signs. So that tells me this really is a local something. Because I go from positive to negative, I know it's a local maximum. Now this one right here, again, my tangent line slope is going to be 0. But prior to it, it's negative. And after that point, it's positive. So again, the first derivative changed signs at this value of x. See, now I went from negative, going from down to positive up. That tells me that's a local min.